Hello and welcome. As part of my data analytics course, I will talk today about some important concepts of data analytics. Hereby, I will answer 5 questions. The first question is about the CRISP DM methodology for data mining. CRISP DM is short for Cross Industry Standard Process for Data Mining. The picture shows the process for data mining. The process starts with the first step of the process is business understanding. Here we will analyze the business, its competitors, its surroundings, its resources, and the industry to get a better understanding of the business and to better tailor our goals. The second step is data understanding. Same with business understanding. We will look at our data. We will create a data dictionary where we put all important information like what scale the data has, where the data is stored, how the data is connected to each other, and a description of what the data and the values show. The third step, data preparation, is one of the most crucial. Here we need to prepare our data for the next step. We look at missing values, duplicates, statistically outliers. This process as well has to be well documented and commentated so that our team members and our customer can later on review the steps we did for the next part. The modeling, here we will have an algorithm or mathematically calculations which use our data to produce thoughtful insights and trends. The fifth step is evaluation. This is also important as we look at the outcomes of our models. We have to evaluate them if they meet the conditions like validity, reliability, and objectively. The last step is deployment. Here we will use our model and use it for the real business world. Before though we can deploy our model, we have to redo all the steps. As the model, as on the first try, we will never get a perfect model. It is part of the process and as you can see, the cycle, to always evaluate your outcomes and to try to improve your model as then the insights get better and more useful. Here in this picture, we will see the process a bit smaller. The total is used interdisciplinary. It is used in computer science, software engineering, and psychology and other disciplines. We have a set criteria. We have to test it, operate, test, operate, test. This is what we have to calculate as well, that a model takes time and it has to be tested several times before we can finally deploy it. The last thing is autocorrelation. Correlation in general is a relationship between two variables. Autocorrelation here in the sense is that it's a relationship between the past and the future data. So that the data from the past is useful to predict the future data and future outcomes. A third more theoretically conditions are the Gauss-Markov. These are conditions and tests we can use for regression to better validate our results of our regression models. If we, for example, are not moving or are we in a sleep, this is the pulse, the human pulse. We can see stationarity, we have a repeating pattern. It goes up, it goes down, it stays, goes up and gets down. This is the most easiest way to spot stationarity or seasonality. In contrast, seasonality, this is a pulse when we do sports, or here it's a marathon. We can see that the graphs go up, the pulse goes up and down, but it doesn't have a repeating pattern, so we can see its seasonality. The third question is about data ethics and the principle of data ethics. First is ownership. You are always the owner of your data. You might come across when you want to enter a website that you have to either agree or disagree to certain conditions. Here you give the permission that the company can use your data. This is also the part of transparency, where the company shows you what data they collect and how they're going to use the data. The third is privacy. Here we have the personal identifiable information like birthday, age, your full name, addresses, email accounts, bank accounts, even social security. A company has to make sure that these information are stored, secure, encrypted, and are not accessible by third parties. The fourth is the intention. Here as well, if you enter a website, the company gives you a description of how or why they're going to use your data. For example, to better tailor their ads towards your interests, or maybe to record your data for scientific purpose. The outcome is now what the company does with your data. It should always be it should always be in a way that it's not harmful for you or other groups. That is why data ethic is as well part of the corporate social responsibility. A company has to make sure that your data is stored securely and that it's not use your data to harm you or any other persons. In the fourth question, we talk about biases. In the example, we are part of a financial service company and found biases in our predictive model. Now the question is how we would raise our concerns and also suggest measurements to avoid biases. First of all, biases in financial services can have huge impacts on people's life. If, for example, the model takes into account personal information like beliefs, background, demographics, skin colors, or others, and then based on this, higher or lower credit score can have huge impacts on people's life. And as we talked before, it is not the intended outcome and it's not data ethically. If I would find something like this, I would first ask more experienced team members and ask for their opinion. If they agree with my findings, I would then ask my manager to set up a meeting with everybody and talk about these concerns and find ways to improve our model and to make it more objectively. The second question, how to avoid biases, is as well part of data ethics. In a company, we should have a corporate culture where we can easily raise these concerns and talk about these concerns without being harmed in our position. In the fifth question, we talk about the difference between regression and classification models. Regression models are part of a confirmatory analysis. In confirmatory analysis, we try to confirm our thoughts or theoretically constructs. For example, if we would say that ice cream sales go up with rising temperature, we can use, for example, a linear regression where we put ice cream sales on one x and temperature on the other x. We would see with rising temperature our sales go up too. This is a linear regression. Classification on the other side are part of exploratory analysis. Here we try to explore trends or insights in our data. For example, a cluster analysis. If we would take, for example, cosmetic sales in general, we would have, for example, an average spending mean for men and an average spending mean for women. And now we would build clusters around these two means. So we have one lower mean, one higher mean, maybe a mean in between. And then we will cluster, or we will separate our data into three clusters, which means are closer to the mean of a cluster. This is a part of a classification or exploratory analysis. Thank you very much. This was it for me. I will come back later. Bye.